I've had a ton of people ask me to make a video dedicated just to my electrical system. And if you can't tell by the title of the video and the bench missing with all the batteries showing, that's exactly what's going to be happening today. Before we get started, I just want to say this is obviously not the only way you can build an electrical system. There's low, medium, and high price points, and different components and parts. This system I built is just one that fits our needs and what we're going to be using the truck for. And as you can see from this quick time lapse, I only use Victron Energy parts. They are by far the most well-rounded, best ecosystem of products on the market. You can monitor and manage pretty much anything once they're all linked together from the screen in the truck or the app on your phone. And once I move all the components into the vehicle, it's just a matter of bolting down the batteries, crimping the wires, getting them all to the right length, fusing everything, linking everything together, and turning it on. Electrical systems are one of those things where it's not really worth it to save money on. Say you have a full build list, it's always better to put the extra money into electrical and then take away money from another aspect of your build. And with all that being said, let's finally dig into the system here. I'll go through it from top to bottom, and I'll kind of do it in the way that it flows to kind of give people a sense of the path that it takes from coming into the batteries to leaving to the lights and everything that works inside of the vehicle. As I go through this, excuse some of the wiring on the sides and in the back. I'm in the midst of redoing a bunch of the rerouting and cleaning up of the cables, and I just decided to also make this video at the same time. So let's dive into some numbers here. The system is pretty large in comparison to a traditional electrical system. Right now in the bottom, I have four 24-volt Epoch 230 amp hour batteries, which gives me a total of 920 amp hours at 24 volts, 1,840 amp hours at 12 volts, or 22.1 kilowatt hours. So now that we have all this battery power, we need to figure out how to get it into the system so we can power everything that we need to. Which is where this comes into play. It's called a Lynx distributor. And all that this is a bus bar. And a bus bar is basically a fancy name for a bar of copper that you can connect multiple terminals, both positive and negative to. The reason why this is the ideal way to go, even though the batteries are still all wired in parallel, they're not connected to each other, so to speak. Through these fuses, each one has its own separate line. Say number 2 goes because of a blown fuse or a short circuit or a malfunction. If these were wired in a traditional parallel, 1, 3, and 4 would backfeed themselves and try to revive number 2. And that's not good because we can't revive a dead battery. So having them like this, say fuse 2 blows. 1, 3, and 4 won't care, and it'll just basically be like I have a system of 3 batteries, meaning wherever we are, I could have 3 of these go out and we would still be able to get by, at least to run basic necessities with just 1 battery. Following along to the left, everything here goes basically from the right to the left. I kind of have it backwards. But after the main distribution block of the batteries, it goes to a massive BEP 600 amp kill switch, and it does exactly what you think it does. If I flip that knob to the red, it kills my entire system in case of an emergency, or if I'm not going to be in the truck for a long amount of time, it's just a dormant state basically for my system. Moving down the line, the next item in sequence is called a shunt, and this basically allows you to not be blind. Think of it as a fuel gauge for the battery bank. Every bit of power that goes in and out of the system, whether you're charging off solar or using a toaster, every single amp hour that comes through the system is shown through this and displayed on the screen so you know exactly what's happening at any point. Although it does a really good job of controlling and seeing what's coming in and out of the system, it doesn't have the ability to show it on a screen or to translate what it's feeling. Which is where this little thing comes into play, and it is the entire brains of the whole electrical system. It's known as a Cerbo GX. And in some way, shape, or form, every single thing in my electrical cabinet is displayed through this little device. Now you're probably wondering, yeah, that's cool that this is translating everything, but still, how do you see it? And now I'll show you some of the most ridiculous things about my system. You can control it from your phone, which shows everything from solar to temperature to humidity. to on a computer where I can click on the Cerbo GX, I can click on the global link, I can click on the solar, and then the main thing that we use is the screen that's hardwired to the battery system. Some features of the screen, starting from the top left, you can see if we're connected to shore power. We have solar yield. Obviously that's 0.6 of an amp hour because it has been raining here for the past 2 days straight. We have alternator power, so when the truck is on, this will read the value that is being put into the battery bank. We have inverting because the inverter is always on, and we have a 1 amp AC load, which is pretty much nothing. And our batteries, we're at 41%, 26.2 volts. We're losing 4 amp hours overall of DC and AC, and a total of 112 watts that fluctuates. Moving on from the overview page, you can click on the levels on the bottom, and this brings up all the habitat and external information. So right now we have the habitat temperature at 71%, and I have 2 other sensors as well that I have just turned off right now because I don't use them all the time. But one measures the temperature and conditions of the cab, and the other does outside, so I'm able to see at least temperature and humidity before we ever leave the habitat. The second tab on the level screen are for tanks. You can have freshwater, gray water, propane, diesel. Anything that is a consumable can be recorded through here. Right now I only have the water, and as you can see we got about 49% water left, and on the screen it will increase as we fill and decrease as we use. There's also an alarm built into this, so if we get below 10%, the alarm kicks on, and if it gets above 95%, the alarm will also kick on just to let me know that it's full. So that was a rundown of how the batteries are connected into the system and they give the power to where it needs to go. Now I'm going to show you guys how the batteries are able to be charged and how they receive the power to stay alive. This is a secondary Lynx distributor, and it is responsible for handling and distributing all the power for where it needs to go. Starting from the left to the right, we have the 12 and 24 volt panels, we have the alternator charger, we have the solar, and then lastly we have the inverter. Given that this is a 24 volt system, we need a way to change that 24 volts to 12 volts to power all the accessories in the truck, which is where this simple box comes into play. It's called an Orion DC to DC converter, and all that it does, it takes 24 volts and steps it down to 12 volts. Now that we have 24 volts converted down to 12 volts, we then have to send that off to the separate parts of the truck. One fuse panel goes to the passenger side, and I have another one that goes to the driver's side. And the reason why we have 2 fuse panels is pretty simple. I split the truck down in half and divided the passenger side from the driver's side. On the passenger side, we have things like the diesel heater, the fridge, the lights. So if any of those go, I know to look at the separate fuse panel on the right-hand side. Same for the driver's side. If the hot water tank goes, the water pump goes, the shower lights go, I know that is the left-hand side, so I'm able to diagnose that within seconds versus taking all the fuses out and checking each one individually. Next on that list is going to be the alternator or the DC to DC charger. What this product does in the path that the power flows, it comes in from the alternator when the truck is running into this product here called an Orion XS 1400. From here, it is all Bluetooth controlled. You can regulate the power coming in from 1 amp to 50 amps. Comes in from the alternator to this, over to the distributor block, and then from here, back into the batteries, all while the truck is running. Next on the list from the main distributor is going to be the solar, one of the most important parts of the truck and what makes this a truly off-grid vehicle. So the path it takes, I have 1900 watts of solar on the roof. It comes down through the wall and into my MPPT, or otherwise known as my solar controller. And then from there, it simply goes back to the distributor and then feeds it into the batteries, giving us power. To give you a bit of an idea of what that means, the mini split is never off. Whether it's heating or cooling, it's always on. The fridge is on, Starlink, dehumidifier, and even down here, I have my Bamboo Labs X1 Carbon, which is pretty cool because anywhere we are in the world, if something breaks or needs to be redone, I can do so as long as I have electricity. But of course, it's not always going to be sunny. So if we forget about the solar, I could still run everything with no sun, never turning the truck on, and never hooking up to shore power or even a generator for over 6 days without needing any other source other than those batteries. These are all like luxury things or creature comforts that I don't need to have on, and if it ever became a scenario where we truly didn't have any sun or any form of external power, we could technically run for 3 to 4 weeks on the bare minimum just to get by. And as long as we had a source to grab water from, then we would be completely fine. Just a quick example of that, the AC is on, but the compressor shut off, so obviously it'll be a little bit higher for that. But completely cloudy and still raining. We're still gaining 9 amps an hour of solar with the dehumidifier on, all the lights, and the 3D printer. Only losing 4 to 5 amps an hour, meaning with all this stuff still running, we're gaining 2 to 3 amps an hour, which again isn't much, but it's still being net positive from what we're producing versus what we're using. And the next part on the list after those main chunks is going to be my inverter, which is kind of my most used in terms of power provided, but my least used in terms of power given. I rarely have ever hooked up to a shore power or needed an external source of charge. It takes the 24 volts from the battery and steps it up and inverts it to 120 volts, meaning all household items. Outlets, 3D printer, mini split, anything that you would typically see in a home is what's fed by this. If we take a look at the back of the breaker panel, you can see this is where every single wire for an AC circuit is coming from. This is your main power in. It's a 600 volt 6 gauge triplex wire, and all these smaller ones simply just go to each of the AC outlets throughout the truck. A quick recap on everything that's connected to the Lynx distributor that makes all of this its own system. You have the AC inverter, you have solar, DC to DC, which is the alternator, and then you have all the 12 and 24 volt circuits. Now it's time for everyone's favorite topic or area of conversation. How much did that cost? I got my computer out in front of me. I'm going to break it down just in generic chunks. But before I get into that, I knew when I was designing it that this one was going to hurt the pockets. I've built plenty of electrical systems in the past, and they all use the same components, but not as extravagant and as detail orientated as this one was. So I'll start at the top of the list with the biggest most expensive items and then work my way down to the bottom. And if you couldn't guess, the biggest item, both size-wise and price-wise, are the batteries. We went with the Epoch 24 volt 230 amp hour version 2 batteries. Each one of those ran $2,400 with shipping. All four came to about $9,800. Next on the list would be the Victron components, so all the pretty blue looking items that you saw under the bench there. That's including the inverter, the distributors, the alternator charger, everything. Those all came to $4,925. Solar panels, which I didn't show you, but they're on the roof. Those came to about $1,500, and they're actually pretty reasonably priced. Mostly that price was shipping, unfortunately, because of the size of them. Wires, fuses, and miscellaneous hardware like the extrusion and everything, that was $3,500 in itself. Those cables and the wiring is very expensive, especially if you go with a high quality, which is crucial for corrosion prevention and fire rating for RVs and marine life. And yeah, I guess that's a very small list, chunking everything together. Came into right under $20,000, and I'm sure it's probably right at that or a little bit over. I just don't have like every small like zip tie or everything labeled. So the electrical system, if you're looking for one of this size or configuration, it'll run you anywhere from $17,500 to $22,000, depending on how specific you really want to get with it. Or if you want to add more batteries, the price will just keep going up. But let's be honest, taking this 24,000 pound brick to some really remote places and some extreme climates, it's inevitable. Things are going to break. I mean, regardless of how much work I did to it, it's still an old military vehicle. So wherever we do break down, I'm hoping it's a good view, because we'll be set up pretty well and have plenty of power to enjoy it. And with that being said, that's the ending to the video of the overview and the design and the function of the electrical system in my truck. Thank you guys all for the support and the likes and the comments. It's pretty cool to see other people interested and engaging in the things that I'm working on. A few more weeks left and we'll be finally hitting the road and going on such a cool adventure. We truly have no idea where it's going to take us, but we'll be going to some pretty cool places, doing some cool things, tons of hiking, a lot of drone footage, vlogging, and of course content on the truck. I'm excited to finally go out and put this thing to the test, and then after that road trip, starting our next project. And it's just going to be as cool, if not more unique than this. So I hope you guys continue to stick around. I will be posting every Saturday or Sunday, or every weekend from here on out. So thank you all again, and one last time, I appreciate everything, and I'll see you guys in the next one.